All right, for day 4, we're going to look at a new idea. It's areas in general and then areas of triangle using a couple different methods. What is area is given any shape, it's just a construct which says how much is inside. So what it helps us is if you have two shapes, we look at that number associated with how much is inside it, and then we can say which is larger and which is smaller and so on. One way to do that is that we define a square of side 1 and we say that the area is 1 times 1, which is 1. Whatever unit, let's say I choose meter as a unit, then it's going to be 1 meter times meter or 1 square meter. Now, if I have, say, a rectangle, and the rectangle is, let's say, 2 meters by 3 meters, what I can do is I can divide this rectangle into 6 parts, all of which have an area of 1 meter squared. So the total area of the rectangle then becomes 1 added 6 times, which is 6 square meter, which can also be seen as 2 times 3. And so you get this general notion of area of a rectangle as length times the width, because you're just counting small boxes of size 1. Now, simple case of a triangle is if it is right angled. I left this as an exercise for you to do to find this reason. It's fairly simple. If you look at this right triangle and the height is x and the base is y, if I make another copy of this triangle, then what I get is a rectangle. So the area of the rectangle is x times y, but because it's a copy, the area of the triangle is 1/2 times x times y. A lot of times you will see this formula written as 1/2 times base times height. Now it's not necessarily only for right angle triangle. If I have any triangle, say something like that, if this is the base, the only difference is that the height has to be perpendicular, which means I need to have a way of measuring this h even if that is the given triangle. Now the last thing for this week's material is something called Heron's formula, which is a really cool method in which you can find area of any triangle as long as you know the 3 sides. So there are 2 steps involved. You find S by taking the perimeter and halving it, and that's why this S is also called the semi-perimeter, because it's half of the perimeter. And then the area is square root of S times S minus A times S minus B times S minus C. Let's look at an example and I'll give you sort of framework for how to approach the calculations. So let's say A is B 7 centimeter, B is 9 centimeter, that makes it 16, so C can be 8 centimeters. So first step is find S. S is going to be A plus B plus C over 2. It's either going to be a whole number or half. So this comes out to 24 over 2, which is 12 centimeter. Now step 2, I'm going to break down into a few different steps. I already have S. Let's say I calculate S minus A separately. So 12 minus 7 is 5. S minus B separately, 12 minus 9 is 3. And S minus C separately, 12 minus 8 is 4. So let's call this 2A. And then in 2B, I find the area as the square root of S. So you plug in 12, 5, 3, 4. The square root of 12 times 5 times 3 times 4. It comes out to 26.83 centimeters. Or if you would like to do it directly, you can do it in one step, and just making sure you use parentheses when you plug these into the calculator. So you have to plug this as is in the calculator for it to make sense. And that should also give you the same result. All right, that's it for areas and this week's material.